Hello and welcome to another video. Today, I'm diving into something a bit different. AI. I know it's a topic that sparks a lot of debate, with some people loving it and others not so much. Personally, I think it's incredible. The recent advancements in AI have been nothing short of mind-blowing. And for artists, there are some truly amazing tools out there that can make our lives a whole lot easier. Today, I'm excited to talk about a fantastic tool called Hunyuan 3D-2, developed by Tencent. You might have heard of it. Essentially, it generates 3D models from either a text prompt or a 2D image. I thought, wouldn't it be amazing to have this tool right within Maya? So, I teamed up with another powerful AI, ChatGPT. And with its help, I created a simple script that lets you integrate this tool directly into Maya. Before we get started, there are a few prerequisites you'll need to install. Don't worry, I'll walk you through the entire process. There will be a bit of Python command line work, but I'll guide you step by step, so it'll be easy to follow. I should mention that this tool is only compatible with NVIDIA GPUs. So if you have an AMD GPU or an Intel GPU, I'm sorry, but this tool won't work on your machine. With that out the way, let's go over what you need to install before we get started. First, you'll need Git. Just head to the link in the description, download Git for Windows, and install it. Simple as that. Next, you'll need Python, but don't just grab the latest version from the website, because that won't work. You specifically need Python 3.11 something. Doesn't matter what the last number is. I'm using 3.11.7, but as long as it's 3.11, you're good to go. The link is in the description. Just scroll down, find Windows Installer 64-bit, download it, and install. And this part is important. When you run the installer, make sure you check Add Python to Path. Otherwise, you'll have to set it up manually later. Now onto CUDA Toolkit. You'll need version 12.4. You can install a newer version, but I recommend sticking with 12.4 to avoid compatibility issues. When you go to the download page, select Windows x86-64, pick your Windows version, and choose EXE Local. Then, download and install. Just a heads up, you'll need an NVIDIA account to get this file. And finally, you'll need Visual Studio 2022 Community Edition. Again, link in the description. Just click on Community, download it, and install. Once you've got everything installed, restart your computer to make sure all the changes take effect. Once you've restarted your computer, there's just one last thing to install: PyTorch. Head to the link in the description and make sure to select the same options as me: stable version, Windows, pip, Python. And since we installed CUDA 12.4, make sure that's selected as well. Now, you won't actually be downloading a file here. Instead, you'll see a command. Just select it and press Ctrl-C to copy it. Next, press Windows plus R on your keyboard, type CMD, and hit Enter. In the command window, simply press Ctrl-V to paste the command, then hit Enter to run it. I won't be running it here since I already have PyTorch installed. But once you do this, it'll install PyTorch for CUDA 12.4. Alright, now you should be ready to install Hunyuan 3D. First, head to the link in the description. You'll need a Hugging Face account, so if you don't have one, you can either create a new account or just log in with Google. Once you're in, scroll down until you see GitHub repository, then click on it. This will take you to the Hunyuan 3D GitHub page. Now we need to grab the repository link. Just go to the address bar at the top and press Ctrl+C to copy the link. Next, create a new folder anywhere on your computer. I'm calling mine Tutorial. Once you've made the folder, click inside the path bar at the top, type CMD, and press Enter. This will open the command prompt directly inside your new folder. Now, to install the repository, type git clone and paste the link here with Ctrl+V. Then press Enter. Once it's done, you'll see a new folder named Hunyuan 3D-2 appear. If you open it, you should see the correct folder structure inside. Now, let's go back to the Hugging Face page and scroll down to where it says, Getting Started with Hunyuan 3D-2. Now, we need to run a few commands, one by one. Just follow along exactly as I do. First, copy the first command. Then, go back to the command prompt. We need to enter the folder we just installed. Specifically, we need to go into the Hunyuan 3D-2 folder. To do that, type CD, then start typing Hun, and press the Tab key to autocomplete the folder name. Once it fills in, press Enter. Now, we are inside the Hunyuan 3D folder. Next, press Ctrl+V to paste the command, then press Enter to run it. That's the first step done. Now, we need to move into another folder inside this directory. Copy the next command, paste it into the command prompt, and press Enter. You'll see that we are now inside the custom rasterizer folder. Now pay close attention here. Copy the next command, but before you run it, you'll notice that it says Python 3. We need to remove the 3, otherwise it won't work. Once you've done that, press Enter to run it. This process may take a few minutes, so just wait for it to complete. Alright, now we need to go back 3 times in the directory. To do this, type cd ... and press Enter. That's once. Do it again, press Enter a second time. And one more time, press Enter a third time. Now, we're back where we started. Next, copy the command that moves us into the differentiable render directory. Paste it into the command prompt, and press Enter. Now, we are inside the correct folder. For the final step, copy the next command, but don't copy the whole thing. Just the part that starts with Python setup.py install. Again, if you see Python 3 in the command, remove the 3, then press Enter. This might take a few minutes. If you run into any errors during the installation process, my best advice is to use ChatGPT. Just copy and paste the error message into ChatGPT, and it will help you troubleshoot the issue quickly. There's no need to waste time searching through forums or digging through Google results. ChatGPT will give you a solution in no time. And before you ask, no, I'm not sponsored by OpenAI. We're almost there. Now download the zip file with my Maya script. You'll find the link in the description. Once downloaded, you can extract it anywhere you like. Inside the folder, you'll see 3 files, API server.py, and 2 versions of the Hunyuan 3D generator. I've prepared both Python 2 and Python 3 versions, depending on which Maya version you're using. If you're using Maya 2021 or older, I recommend using the Python 2 version. If you're on Maya 2022 or newer, go with Python 3. Next, take the API server.py file and copy it into your Hunyuan 3D folder. Replace the existing one when prompted. Now, to run the server, let's create a simple batch file so we don't have to type the Python command manually every time. Right-click and create a new text document. Let's name it run_API, then change the file extension from txt to bat. Next, right-click the file and choose Edit. I'm using Notepad++, but you can use Notepad as well. Now, inside the file, type the following. In the first line, we're going to type @echo off. Below, we're going to type Python API _server.py. And at the bottom, we're just going to type pause. Once that's done, save and close the file. Now, just double-click on Run API to start the server. Since this is the first time running it, the necessary models will need to be downloaded. This process can take several minutes, depending on your internet speed, so just be patient and let it finish. Maybe take a break, step outside, and get some fresh air while you wait. Touch some grass. All right, it took a little while, but it's finally ready. Now pay attention to the address at the bottom, especially the last 4 digits, 8081. It's time to open Maya and test the script. I'm going to extract my Python script into the Hunyuan 3D folder, but feel free to extract it wherever you like. There are a couple of ways to run the script. One option is to simply drag and drop the script into your Maya viewport, and the interface will appear. But you'll have to do this every time you run Maya. There's a better way. You can open the script, press Ctrl-A to select everything, then Ctrl-C to copy it. Next, open the Maya script editor. Make sure you're in the Python tab and paste the script. After that, press Ctrl-A to select everything again, click your mouse wheel, and drag the script up to your custom shelf. This way, you'll have easy access to it. To customize it, right-click on the shelf, go to Edit, then Shelf. In the tooltip field, type Hunyuan 3D-2. And for the icon label, I'll just call it H3D2. Lastly, don't forget to click on Save All Shelves. Now, you've added the script to your shelf, and you can just click it whenever you need quick access. So, how do we use the script? First, you'll need to update the local host in the server window. You'll see 8081 there, so make sure to match the 8081 at the end of the API URL. Next, and this is very important, you'll need to set the cache path. Inside your Hunyuan 3D folder, you'll find a folder called gradio_cache. This is the folder you must use. Select the path and copy it. Then go to the tool, click Browse, and paste the path there. After that, click Save. In this section, you can type a prompt, but I'll show you this later. First, go back to your Hunyuan 3D folder. Inside, you'll find a folder called Assets, and within that, Example Images. In this folder, you'll find a bunch of sample images you can try out. For example, let's use this cute dragon image, which is 1123. Click Browse, navigate to the Assets folder, then go into Example Images, and select the cute dragon image. Next, I'm going to explain the generation parameter in details. Octree resolution, Hunyuan 3D2, uses an octree data structure to represent 3D geometry. The octree resolution determines the fineness of this grid. In simple terms, a higher octree resolution means that the model will break the 3D space into smaller cells or voxels, which can capture finer details in the resulting mesh. However, higher resolution also increases computational demands and may slow down processing. Lower resolution will yield a coarser mesh, but be faster and require less memory. Number of inference steps. This parameter controls how many iterations the diffusion or generative process will use to refine the output during inference. In diffusion models, the generation happens gradually through a series of denoising steps. Increasing the number of steps generally improves the quality and detail of the generated 3D model because the model has more opportunities to refine details. The trade-off is that more steps require more time and computational resources. Guidance scale. Guidance scale is a parameter common to diffusion-based models that employ classifier-free guidance. It adjusts the strength of conditioning on your input prompt or image. A higher guidance scale forces the generative process to adhere more strictly to the given condition, which often yields results that better match the prompt, but can sometimes reduce diversity. Conversely, a lower guidance scale allows the model to explore more, potentially increasing creativity at the cost of fidelity to the input. Each of these settings allows you to balance quality, detail, processing time, and how faithfully the output matches your prompt, which is typical for diffusion-based and octree-driven 3D generative systems. Wow, that was a lot to take in. Finally, the Generate Texture checkbox is pretty straightforward. When enabled, it will generate a texture for your model, but there's a catch, which I'll explain in just a bit. For now, I'll go ahead and turn it on, and then click Generate 3D Model. Now, let's Alt-Tab to the server window and check the progress. The speed of the generation depends on both your system specs and the settings you've chosen. Here's the real-time progress on my system with an RTX 3090. When the generation reaches this point, I usually have to wait a couple of minutes for the model to complete. Since we've enabled texture generation, it's going to take a few minutes to compute. If we had turned it off, the process would have been much faster. I'll cut the video here so you don't have to wait. All right, when you see this message, it means the process is complete. And there it is. If I switch to texture view, you can see that the model is fully textured, even on the back where the AI had to fill in the hidden parts. If I zoom in and enable wireframe, you can see the geometry that's been generated. When you turn on texture generation, Hunyuan applies decimation to the mesh before creating the UVs. Now, let's compare the difference in mesh quality when generating without a texture. I'll start with the lowest octree resolution and click Generate. As you can see, the generation is much faster. Now, let's look at the mesh. The voxel resolution is pretty low, but the mesh hasn't been decimated. Let's now crank up the octree resolution to 512 and click Generate. The generation was a lot slower, but you can see that the level of detail is much higher, resulting in a very clean surface and defined features, because the voxel size is very small. So just keep in mind that if you want to include the texture, the trade-off is that the model will be decimated, which means it will lose a lot of geometric detail. Now let's take a look at the UVs. As you can see, they're tightly packed, but since they were automatically generated, the cuts aren't optimal. Personally, I see this model generator as a fantastic shortcut, especially when you need to create a large number of placeholder models quickly. However, if you plan to use these models in an actual production, you'll definitely need to retopologize the mesh, as well as redo the UVs and textures. Nevertheless, I believe this is an incredibly useful tool for 3D artists. One last thing to keep in mind: the mesh might look solid, but the vertices aren't welded. I recommend going into Edit Mesh, Merge options, and setting the threshold to a very small value before clicking Apply. This will weld all the vertices together, creating a watertight mesh, which is especially useful if you plan to 3D print the model. Now, let's try something different. I'll give you a quick demonstration of the text prompt option. This works exactly as you'd expect. You type a description, and the AI generates a 3D model based on it. For example, I'll type simple wooden chair and start the process. However, I won't enable generate texture because, in my experience, it doesn't work well with text prompts. Every time I tried, the generation got stuck, even after 15 minutes, forcing me to restart the server API. Now, here's the result. The model looks really clean and well-formed, but personally, I prefer the Image-to-3D option. For example, if I wanted to make a chair, I could quickly search for IKEA chair on Google, pick an image I like, save it, and then load it into Hunyuan 3D. This time, I'll enable texture generation and click Generate. And here it is. The texture has a few minor issues, but overall, it looks pretty solid, especially considering all I did was click a button and wait a few minutes. Manually modeling and texturing this would have taken me way longer. Now, let me show you my favorite method for creating images to generate 3D models using AI-generated artwork. With this approach, I can use one generative AI to create a 2D image of anything I want. Then feed that image into another AI to turn it into a 3D model. It's honestly mind-blowing. Just 2 years ago, this would have felt like something straight out of science fiction. And now it's not only real, but it's also free and accessible to everyone. Crazy. For this, I'm using Comfy UI, a popular tool for generating AI images and videos. I won't go into detail on how to install it here. That would need a whole separate video. But don't worry, there are plenty of tutorials on YouTube that cover the installation process. For the AI model, I'm using Flux Schnell because it's fast and delivers high-quality results. Now, in the text prompt, I could type something simple, like a Chesterfield chair, white background. But Flux works best with long, detailed prompts, so I like to let ChatGPT expand it for me. Pretty cool, right? Once I get a more descriptive prompt, I just copy and paste it back into Comfy UI and generate a batch of images. When that is done, I just pick the one I like the most, load it into Hunyuan 3D, and click Generate. Super easy, barely an inconvenience. And here it is. The texture could use some work, but the mesh is pretty good. All right, I've generated a variety of prompts featuring different characters and converted the images into 3D models. Here is what I got. I'll show you the images so you can judge for yourself. First, there's this alien dude. The model seems pretty clean. Then this red-skinned girl. The texture isn't great, and some of fine details, like the fingers, didn't come through very well. But overall, the body shape turned out nicely. Next, this monkey character, which I think came out really well. And finally, I created a few cute robots made from old radio parts. I really like these ones. They turned out quite solid overall. Finally, I will demonstrate how to transfer textures from a decimated model to a high-detail version. As you can see, the difference in geometric detail is quite obvious. However, the high-detail mesh doesn't have any UVs. I'll show you how to fix that. First, move the decimated model into the same position as the high-detail model. Then, hold Control and select the high-detail model. Next, go to the top menu and navigate to Mesh Transfer Attributes options. Reset the settings to default, then click Apply. Once that's done, don't forget to go to Edit, Delete All by Type History to clean things up. Now, open the Hypershade menu. Select the high-detail model. Right-click on the material from the decimated model and choose Assign to Selection. And there you have it, a high-detail model with proper UVs and textures, all set and ready to go. Pretty simple. This wraps up this tutorial on how to use Hunyuan 3D in Maya. I hope you found it helpful and maybe even learned something new along the way. Before we finish, I'll leave you with a short video I put together earlier. In it, I used Flux, ChatGPT, and Hunyuan 3D to generate a bunch of items, and then built a quick scene in Maya. Heads up for headphone users. There's a song playing in the background that I also created using Suno AI. Since this whole project was AI-powered, I thought it was only fitting to use AI for the music too. If you enjoyed the video, feel free to leave a comment, share it, and subscribe to my channel. I'd really appreciate it. Thanks for watching, and I'll see you in the next one. Bye.
In my digital lab, got a new best friend. It's an AI powerhouse, it won't pretend. Spinning shapes from code like it's Play-Doh, cranking out cool models in a single flow. Oh, let it go, let it fly. 3D magic in the blink of an eye. Save the time, feel the vibe. Everybody's gotta give this AI a try. Automate my world, build a neon dream. Pixel perfect wonders, oh it's quite the scheme. Take your vision